In this video, I'll explain about binary operation. A binary operation star on a set A is nothing but it is a function from A cross A to A. So the binary operation name says it always requires two operands, binary in the sense two operands or two inputs. On those two inputs, this operation is performed and it gives you some output. The requirement is that whatever output you obtain, that should belong to the set A. Means take two elements from A and operate that operation on those two elements, and you will get an output. That output also should belong to the set A. And the second condition is that the output what you obtain for every possible inputs should be unique. Means every possible input should give you only single answer, not more than one answer. Then such operation is called as binary operation. So it is a function. Basically, binary operation is also a function, which is a function from A cross A. A cross A is nothing but the Cartesian product, and the codomain will be A. Take inputs from the Cartesian product of the given set, and the output should belong to the same set A. Every ordered pair in A cross A is mapped to a unique element in A. Then that kind of operation is called as binary operation. Examples: on the set of all natural numbers, addition and multiplication are binary operations. It is very clear, like 2 plus 3, it goes to 5. 5 is there in n, and 2 plus 3 is giving you only one answer, 5, not more than one answer. So both the conditions, uniqueness and every element of n is mapped to unique element of n, that is satisfied. Therefore it is a binary operation. In the case of multiplication also, same thing holds. On the set of all natural numbers, subtraction is not a binary operation. That is because take any two elements from n, 2 comma 3. 2 minus 3 is equal to minus 1. This answer is not there in n. Whatever answer you get, that should be there in natural numbers. That is not happening here. Hence it is not a binary operation. On the set of all real numbers, if I defined the binary, these are the basic operations like addition, subtraction, multiplication and division. Basic operations, they are binary operation on few of the sets and few not on the few other sets. Now if I define a binary operation in this way, this is how I am defining a binary operation. These are using the some basic operations. A star b equal to ab by 2. Here multiplication and division both are used combined together to define a new binary operation. Now this is a binary operation on the set of all real numbers. That is because take any two real number, multiplication is a binary operation on that real number, and division is it is divided by a single value 2, hence that is a single particular value 2, hence it becomes a binary operation. On z, set of all integers, if I define a binary operation as a star b equal to a to the power b, then this is not a binary operation. That is because you can take one example, that is 2 and minus 3. 2 star minus 3 is 2 to the power minus 3. 2 to the power minus 3 is 1 by 2 cube, which is equal to 1 by 8. That doesn't belong to z. 1 by 8 is not an integer. So these two are integers. After taking these two integers, what answer I get, that is not an integer. Hence it doesn't satisfy the condition of binary operation. It is not a binary operation. Now there are different types of binary operations like commutative binary operation, associative binary operation. Let us see one by one what these are. Commutative means a star b equal to b star a. Means if you have taken two elements, if you operate the given operation on those two elements, irrespective of the order taken, the answer remains same. Like 2 star 3 equal to 3 star 2. 2 first, 3 next, or 3 first, 2 next, doesn't matter. In both the cases, if that operation gives you the same answer, we call that operation as a commutative binary operation. On the set of all natural numbers, multiplication is a commutative. That is because 2 into 3 is always equal to 3 into 2. On the set of all integers, subtraction is not commutative binary operation. So first of all, it should be a binary operation. On z, subtraction is a binary operation. On n, it is not a binary operation. If it is not a binary operation, don't go for checking commutative or not. Commutative concept comes only if it is a binary operation. On the set of all integers, subtraction is not a commutative binary operation, because if you take 2 comma 3, this ordered pair, 2 minus 3 is not equal to 3 minus 2. Both are giving you different answers. 2 minus 3 gives you minus 1 and 3 minus 2 gives you 1. Minus 1 not equal to 1. Hence, it is not a commutative binary operation. Now, second type of operation is associative binary operation. Here also A star B star C equal to A star B star C. Means here B and C are taken first, then the answer is operated on A. Here A and B taken first, that answer is operated on C. In any cases, if you get the final answer same, then we call such operation as associative binary operation. Let us take on the natural numbers. Addition is associative binary operation. You can check with that. 2 plus 3 plus 4, which is same as 2 plus 3 plus 4. This gives you same answer. On the set of all integers, again same, minus, that is subtraction is not associative binary operation. Take any example for that matter. As you have seen, it is not commutative, it also gives you not associative. Now, how to find identity element with respect to the given binary operation? First, you should know what is meant by an identity element with respect to the given binary operation. An element E belongs to A, we name that element as E, is identity element if A star E equal to E star A equal to A. That means if you operate that particular element on any element of the given set, you are supposed to get the same element. Then such element is called as identity. Identity means after performing that operation to on any element of the given set, it gives you the same element. It remains the same even after performing the operation. It remains the same. It doesn't make any change to the element. That's why the name identity. So such element is called as identity element if it exists. It need not exist always, but if it exists, then we call it as identity element. So on the set of all real numbers, let us take A star B equal to AB divided by 2. Let me take this particular operation. You know that this is a binary operation. Now, as we have to find out is their identity. In case identity exists, it has to satisfy this condition, that is A star E should be equal to A. That implies what is A star E? As per the definition, A star B is AB by 2. So this gives you AE by 2. In the place of B you have E, which is equal to A as per the definition of identity element. So AA cancels, E equal to 2, and you know that 2 is clearly a real number. So that element should exist in A. Otherwise, we don't say it as identity element. That should be there in A also. Clearly 2 belongs to R. Therefore, identity element is 2 with respect to the given binary operation star. If you change the binary operation, identity element will definitely change in some other binary operation. It is not fixed for all the binary operations. With respect to addition on set of all real numbers, 0 is the identity element. Whereas in the case of addition on R, though addition is a binary operation on n, it doesn't have identity because 0 doesn't belong to n. On that is what the condition. 0 is the identity element on n. 0 is not identity element because 0 does not belong to n. With respect to multiplication, 1 is the identity element. That is because 1 belongs to n. Now, last concept here is inverse of an element. How to define inverse with respect to a given binary operation? An element A belongs to A is said to have an inverse if we can find another element belongs to A, that also should be there in A, such that A star B, after performing the operation on that given element with this B or B star A, both should give you the answer as identity element. Let us take one example on R. A star B equal to AB by 2. This is the binary operation. If you want to find out inverse of 2, okay, that is 2 star B equal to, I should get E, identity element. As per the definition, A star B equal to identity. I have to find out inverse of 2. So A becomes 2. What that B is, that I have to find out. E is the identity. I already know that identity came out to be 2 in the previous example. So 2B by 2 equal to 2. 2 cancels, B equal to 2. So inverse of 2 inverse is equal to 2. with respect to the binary operation star. Okay, and this 2 clearly belongs to R also, therefore inverse of 2 is 2. Similarly, B star 2 also you can find out, that also comes out to be 2 only, which belongs to R, hence 2 inverse is equal to 2. This is with respect to the binary operation AB by 2. So if you take binary operation as multiplication, A star B equal to A into B, so you know that with respect to multiplication, if 2, then its inverse will be 1 by 2. Inverse of 2 equal to 1 by 2. This is in the case of multiplication, but here the binary operation is something different, that is AB by 2. That's why you got 2 inverse as 2. Here 2 into 1 by 2 cancels, gives you 1. 1 is the identity element with respect to the multiplication. Therefore, 1 by 2 is the inverse of 2. So, any element A will have A inverse as 1 by A with respect to multiplication. Similarly, any element A will have A inverse as minus A with respect to addition. Okay, if it is a binary operation on the given set, then with respect to addition, its negative will be negative element will be its inverse, and the reciprocal will be inverse with respect to the multiplication. These are with respect to the basic binary basic fundamental operations of arithmetic operations of mathematics. But there are some other defined binary operation. In those cases, this is the way of finding the identity element or the inverse of the given element. All elements need not be invertible. If invertible, they will satisfy A star B equal to B star A equal to E. So this is all about binary operations, then types of binary operations, and finding identity element and inverse element of a given binary operation. I hope you understood. Thanks for watching.